So how did we actually end up working together, Sebastian?
That's a really good question. I think I have been observing you for many years in the Cardano space, basically, and I was always a fan of what you were doing with NMaker. That is probably what really brought us together. And then it was a matter of a phone call, actually, to start talking. And that I think we both realized really quickly that we love the vision of what we can build with Masumi, and that from a capability point of view, it is just a perfect match.
Completely agree. I think it makes a lot of sense. You know, we've been in the Cardano space for so long, but we haven't really got the same connections to real-world customers that Service Plant has. So bringing these two things together and then developing agents together with those real-world customers, bringing them on the blockchain and just using the blockchain as the layer in between, the connection layer basically between all of those agents, is really a powerful concept, and I think it's really a good, fit made in heaven.
And it's also not trivial, right? I think what we are trying to accomplish here, if we really deliver Masumi as an AI agent network protocol, and we will have truly millions or billions of agents, it is technically quite a challenge to solve this, right?
Absolutely. It's a challenge in many different ways. I mean, first of all, of course, decentralization is important. We want to build this as an open protocol that anyone can join and that is also secured by the blockchain. So we can't start by going to a blockchain where we feel like this is being controlled in a centralized way. We need to make sure that it's really decentralized and cannot just be captured by someone. But then also the second part that's really important is the scalability, of course. And I think scalability is one of these topics that no blockchain currently has fully solved yet. But if we look at it from a purely like architectural level to it, we see, okay, there's going to be billions of these agents. We need to parallelize them. We need to have a lot of agents run in parallel and interact in parallel with each other. And we both, I think, believe that the UTXO model that Cardano is being based on and built on is really predestined for this kind of use case and for this kind of scalability that we need in the future.
Yeah, maybe let's go one step back. In the blockchain space, people quickly talk about being trustless and being permissionless. People who are not in the blockchain space have a big question mark above their head if they hear this. Can you explain it in really simple terms of why something is trustless and when something is permissionless?
Yes, so in the end, we are in a world right now that is being dominated by big platforms, right? We have big platforms everywhere, and there's people that do nothing else but operate these platforms. For example, Amazon, Uber, even Google, all of these different big platforms that kind of have a monopoly because they can decide what they show you and what they give to you and who can join the platform. And it's basically just a middleman. It's nothing that provides much of value to it. It's just a middleman that you give a lot of power to. So what we want to achieve in an ideal world is we want to cut out the middleman as much as possible and increase the efficiency between two parties. So instead of, for example, Service Plan offering an AI agent and then having to offer it on the, marketplace of some big company, and then some other company coming to buy this agent from this marketplace on a centralized website, what we do is we basically allow Service Plan to offer this agent and interact directly with the customer. And the only thing that's in the middle is a smart contract, so a completely decentralized thing basically, that no one can control, but everyone can use and everyone can see exactly what's going on there. And it's not in the hands of like one single company.
Masumi being permissionless means that no one has to ask you or me or anyone else to participate in the network, correct?
Exactly. So anyone can just come and deploy their own AI agent and offer it as a service to others. And anyone can just buy those AI agents through Masumi. And no one can prevent you from actually doing that. And you could even build your own Masumi frontend, your own Masumi website if you want to. So it's really, truly permissionless, and you don't have to ask us or anyone else to be able to participate.
And the same is true for trustless. You don't have to trust me or you that this is all going right? Because the protocol in the network ensures that everyone is following the same rules.
Exactly. So we have a few standardized rules. So for example, if like payment only goes through if the AI agent actually delivers an output, and you don't just pay and expect the output to come, but you actually wait until the output is there, until the agent can withdraw their payment for themselves.
So there's a lot of discussion in the blockchain space about transactions per second, right? And everyone is trying to optimize, okay, how much throughput can you achieve? In which extent is it really critical for us to achieve high throughput, and what are different ways and what are the different, let's say, advantages and disadvantages of how people or how different blockchains try to achieve high throughput?
Yeah, so there's a lot of different ways to achieve high throughput. I think for us, obviously, the majority of the throughput that we need is going to be for the payments and for the decision logging of the agent's output. Mm-hmm. And in these two cases, you know, it becomes really tricky once we're talking about millions and millions of agents. The reality is blockchains are decentralized and they are supposed to be slow because they are open to everyone and everyone can verify their state and everyone can participate. So they will never scale as much as a centralized database. It's just not designed to be like a centralized database. Every AWS server is always going to be faster than a blockchain. But there are many different approaches to scaling, and I think the most popular one and the one that you know, the world is trending towards is by creating app-specific layer 2s that do one specific task, and you can optimize the blockchain for just creating this one specific task, and you can basically make it slightly less permissionless than the main layer 1, and thus say, okay, now we're going to do the majority of the transactions on this specific layer 2 for Masumi, and then just save the output and save the output on the layer 1 again every day, for example. Mm-hmm. And then you can still verify, okay, this is all legit. So
why is it so important that Masumi is working on a blockchain which is highly decentralized? I think it is key to understand, like, how could this be compromised, right? And the decentralization factor is always, to explain it really simple, it's about how many parties do you basically have to compromise, right, to change something in the blockchain and to change a record. Is this a correct understanding? I think that's a perfect understanding, yeah. You know, it's really important if we're building a system like this that could really influence the future of humanity in a way, and if we're really going to scale up to millions of agents or billions of agents that interact with each other every second of the day, then it is extremely critical that we are not giving the power over the system to one company, because otherwise we are creating a monster, and we're actually creating, you know, singularity and what do you call it? Singularity net from Transformers and not Transformers, Terminator. Oh my God, I shouldn't start talking about movies. So yep. Some blockchains simply, they achieve high throughput because they sacrifice on decentralization, right? Mm-hmm. They have less parties involved. These parties have way more powerful computers basically to achieve higher processing speed. And yes, it is much faster, but it is less secure this way because the amount of people you have to compromise to change the record of the blockchain and therefore undermine the whole system is way easier to achieve than if you have a super decentralized network, which might be slower on the level 1, but is way harder to crack. Exactly. And the choice that we made with Cardano is really good there, because Cardano is probably, by many studies, most famously the Edinburgh Decentralization Index, one of the most secure and decentralized blockchains out there. So I think we really picked the blockchain for the fundamental technology and not because we are you know, believers in one chain or another or one coin or another. So we can probably nerd out for hours about blockchain technology, but our mission is really to make it super simple for the average developer to adopt this, right? So how do we try to achieve this? That no one has to understand this in great detail, nevertheless can develop an AI agent solution which is running on Masumi. Exactly. So what we're trying to do, or what we are doing, is we are building a Masumi node that you can run in parallel with your AI agent. And this Masumi node is going to do all the blockchain work for you. So it's going to create a wallet, it's going to do all the transactions for you, it's going to
accept payments for you. You don't have to really worry about anything blockchain related. And it's all going to happen in the background. So we really are making it as easy as possible. And then in the end, you just get the output and you can see, okay, I'm earning money with this, first of all, which is amazing. But then also, secondly, if you buy agents, you see, okay, now I can verify that the agent actually produced this output by just clicking on this link and looking at the blockchain explorer, basically, and seeing, okay, this is the hash of the output, which is quite a huge step, actually.
So as an AI developer, I don't have to learn a smart contract language. I don't have to get into the details of Haskell, which is quite, quite complicated anyway. This is all not something I have to worry about because they're running the node is open source, it has a RESTful API, people can interact with the API and do all of these things, and they don't have to worry about how this works in detail.
Exactly, yeah. And of course, the main purpose of this is that the AI agents themselves can interact with this node and they can pay for other AI agents themselves without you even knowing in some cases that it's happening. You can just look at the log and see, okay, this is what happened, but you're not the one who has to actively do anything.
Yeah. So there are two key components in Masumi, right? The registry or the registry contract and the payment contract. Can you explain a little bit, super high level, how this all works together? Masumi node, registry, payment.
Yeah, so the registry is basically the smart contract where all Masumi nodes and all AI agents can register themselves on chain so that other agents can find them or customers can find them. And the way we do that is we basically create some metadata that we put on chain and we tokenize this agent, and then we can deregister it or update the metadata, do all these nice things. And if I want to, build a front end or I want to find an agent, I just look on chain in this smart contract and I see all the agents that have been created, basically. The second part, the payment smart contract, is really about enabling agents to talk with each other, and also customers, like actual humans like us, to talk with those agents, and basically saying, okay, I want you to do this job for me, and I'm paying you now with those tokens, with those stable coins in the background, and I'm awaiting the response from you, and once the response arrives at my computer or my agent, I can say, okay, this is legit, and then you get the money. So it's a really nice way of doing interactions because no one has to trust anyone. No one is keeping the money hostage. Like if the agent produced an output, you are getting paid. If the agent didn't produce an output, you are not getting paid. It's very simple, and you're not trusting any third party in the middle. You're not trusting, the customer to sell, and you are not trusting the agent provider to actually deliver an output. It just is all handled via the smart contract.
I see. So every time I delegate a job, I pay the smart contract. The smart contract keeps the money in escrow, so to say, and then the agent who has to do the job, after he did the job, he has to give the proof that he produced an output and that he wrote a hash of the output onto the chain. And this is basically unlocking the money, right? Then they can ask for, okay, I did my part, now give me the money.
Exactly.
So you mentioned stablecoins. I think stablecoins are super important to understand. Maybe can you explain what a stablecoin is and why we think stablecoins are important for this AI agent economy to evolve?
So stablecoins are simply coins that are backed by real-world currency, most often the US dollar. So there's a lot of stablecoins like USDT or USDC that are backed one-to-one with US dollars. And this is very important, of course, because real-world companies still pay their employees with actual money, actual currencies, and you still have to pay taxes with actual normal currencies and not with cryptocurrencies. So we need to have this in place so you can actually calculate the costs and calculate the profit as well in a nice way. Obviously, in the future, we are all hoping and thinking that crypto is going to take over, and then at some point stablecoins become irrelevant. But at the moment, it is definitely necessary.
So the benefit of using a stablecoin for a developer is that he doesn't have to worry about the crazy fluctuations of cryptocurrencies, correct?
Exactly, yeah.
He's asking for 100 euros for a service and he's getting 100 stablecoins, and there's no issue in just going to a centralized exchange, show the stablecoins and swap it against US dollars or euros, for example.
Exactly.
Nevertheless, there's a second coin involved, right? Can we explain what this is and for what do you need a second coin?
Yes, so we are introducing the Sumi coin, and the Sumi coin is basically going to be the ecosystem coin for the Masumi network. So there will be a variety of different things that you can do with the Sumi coin. And we are basically layering it out into two phases. So phase number one is all about registering your Masumi node and also creating a reputation by creating a reputation smart contract that we are developing, and a bunch of other stuff that we will talk about in due time. But then phase two is really interesting because we go back to the scaling here. That's really when we are talking about our own layer 2 and our own blockchain, and then we have to pay the operators of this blockchain, of course, in some sort of way. And then we are going to pay them in this Masumi or Sumi token, essentially.
Cool. And then there's a third one.
Oh, what's the third one?
The third one is ADA, obviously. So why do developers still need ADA?
So since we are building it on the Cardano blockchain, ADA is being used as the transaction fee currency. So every time you do a transaction, you have to pay the transaction in ADA. But we are hiding this as much as possible from the end customers and the agent providers. So we are really putting it in the background and making sure that you don't even have to really worry about it. But if you're interested in it, what's going to happen is essentially every time you pay an agent, there's going to be some ADA sent with it, which then gets paid out to the operators of the Cardano network.
Okay, so to sum it up, there are three basically tokens. First one is a stablecoin, which we will be using so that the developers get paid in stablecoins and pay others in stablecoins. This is easy to swap at a centralized exchange. I just have to do an account, do my KYC process, and then I can swap it against the stablecoin and get started. Then we handle a little bit in the background that they have enough ADA to pay the transactions to do this. This is basically the money for the network, right? To basically pay for the service that this is being validated. And the third one is more our utility token, our governance token, which might be, which is Sumi, right? To do all this functionality we have in mind right now, and which plays then a crucial role for the level 2. So let's explain a little bit for beginners the difference between the level 1 and the level 2.
Yes, so the level 1 is basically the public permissionless blockchain that everyone can join at any point, and the idea of it is that it must be as decentralized as possible, because this is basically the source of truth, right? This is where you go to take a look and you need to know, okay, 100% what's on there is correct. And they, like most layer 1s that are successful, have been around for many years and have been proven to be secure and to be decentralized for many years, because if you can hack them, there's a lot of money waiting for you. So it's like a honeypot, and no one has been able to hack it yet, at least with Cardano and Bitcoin. And the layer 2 is basically a second blockchain that we can spin up, which is only designed to help us do the transaction that we need for Masumi. And we can specify the layer 2 to only also accommodate the kind of transactions that we need, and we can also specify how decentralized we want it to make. So we could say, okay, this is in a way very centralized. Only Service Plan has a node controlling that, but we're not going to do that. We are going to open it up to a few more, so that many people can join. But by keeping it relatively small, we can guarantee that the transaction speed is much higher than on the layer 1. And then the way we combine those two is we basically say, okay, now everything that we've done on this layer 2, we are taking and we are putting as a result on the layer 1 every X days, X hours, whenever we want, basically. And that way we can find a good compromise between the security of the layer 1 and the speed of the layer 2.
Okay, I see. So basically, that is the trick blockchain has come up with to reach scalability, right? So everyone knows level 1 will always be slower than anything else, and it's not fast enough to do billions of agents in parallel. And therefore, you are basically introducing the second layer, which is way faster through different measures, but it's still inheriting the security of the level 1 because you do checks and write back to the level 1, and therefore you can always validate that what is happening on the level 2 is also on the level 1, and then it doesn't matter anymore that it's slower on the level 1.
Exactly.
Level 1, level 2, level 1, level 2.
Yeah.
Level
Level 3 also.